limiter chain in place. The limiter chain is pretty much just to hold the blade of the arm back there so it doesn't get hung up on the concrete step up that the calves stand on. Here we have a model mock-up of our motor and motor mount. The cylindrical piece you see in the back with a square top on it, that's our gear motor, and the T-shaped part is the motor mount that was bolted to the floor. Here's the final overview. You can see the motor in the back there, the I-beam and the alley scraper sitting in the center of the alley there, and the barn as a whole.
Good afternoon. So once our design process in SolidWorks was done, we started fabrication. So one of the tools that we used was a milling machine. So a milling machine will have a cutting tool held here in a collet in the machine spindle. And then your workpiece will then be clamped in a vise, which is bolted to the bed of the machine here. And that can move in 3 directions as defined by the blue arrows there. And you've heard a bit about those earlier as well. Here we can see Colin using a milling machine and some actual SolidWorks prints, so we don't just talk about them in presentations, we do actually print them off and use them. Another tool that we used was a MIG welder. So you have a handset here, and then a filler wire that comes out at the end of it. The blue haze around your weld puddle here is shielding gas, so that's going to be a mix of argon and CO2, and that displaces the oxygen in our natural atmosphere, which causes porosity, cracking in your welds, and which greatly reduces strength, almost to the point where it's not worth it. And here you can see I'm doing some welding on the motor mount, which bolts to the floor. We also painted some of our parts, mostly for looks, because it is going in a barn environment, and they will get scratched up and rust, but it made it look good, and it will prevent rusting for some time. Here's one of our first tests that we did. Nothing is really bolted down, but we're just making sure everything works and slides as it should. It actually has, as you can see, enough power to move one of our team members. So when we installed, we had various steps that we needed to do. So one of the first things we needed to do was to drill into the concrete floor of the barn and anchor the I-beam into it, as well as the motor. Because the barn is 25 feet long, we decided to go with 2 sections of I-beam rather than 1. You can buy a stock length of I-beam at 24 feet. But it would have been impractical to get it to the farm as well as into the actual barn itself. So we got 2 shorter pieces and aligned them and welded them together. We also had to, once that was done, install the drive chain here, which you can vaguely see, which is connected here and here to our scraper, and then outside around an idler sprocket, and then back to this side where the motor drives the unit. We also had to place limit switches externally on the barn, which would be out here, and then internally, which would be right next to the motor, to reverse and stop our scraper. And then ultimately run wires from our limit switches to the control box. Here we are the morning of the mechanical install. So we did the install in 2 steps. So we did all of the concrete drilling and bolting to the floor, and then the second day we did the electrical. So just an overview of what we had to do. We had to drill and screw the motor mount to the floor, which is shown in gray. The I-beam in red similarly was drilled and bolted to the floor. The chain is not pictured in this animation, but it would be attached to the green alley scraper there. And then this brown unit here has elongated holes in it, so the bolt pattern of the bearings here and here matched up with those, so that was allowed the idler sprocket to be pulled in or out, thus tensioning the drive chain. This is the preparation, so we were just getting some cleanup done, getting the sawdust out from under where the I-beam would go and any manure that was there. Because if the I-beam is not very clean underneath it and won't mount it flush to the floor, over time it could work those screws loose, or also it could affect how much manure the scraper would pick up and ensure that none was left behind. Here we're using a concrete drill right here. So that uses both a drilling action and a jackhammer sort of action, so it drills and hammers. And that worked very well. That was loaned to us by the BTC maintenance department, and that really sped the process up, worked excellent. Here we have, this is actually two different I-beams here and here, and this is the welded joint, which was welded on site and then ground smooth, so the scraper could slide over that joint. Here is the motor mount. The actual gear motor will be mounted here onto this plate, but is not because John is currently working on the electrical design at the time. Here is the idler sprocket outside of the barn. So this is where the manure would come and dump, and eventually there will be a conveyor here that will take the load of manure that will be dumped out and take it elsewhere. We're just tightening, or actually in this picture, we're loosening the bolts to the bearings on the idler. So this is at the end of day one. So you can see the I-beam is aligned and installed. The scraper is in place, as well as the motor system. So for the electrical install, which was done on the second day, we had to install our limit switches, one on the exterior and one on the interior. We had to run wire from our limit switches to our control box, and then properly connect the wires inside the control box. So here you can see John's fine workmanship here with the finished control box mounted on the wall with the red start switch here. So you would simply push that button and let it run through its cycle and then repeat it. Here are the two limit switches. This one here is exterior, so the scraper will come out of the barn, hit this arm here, trigger the switch, let the motor close down and then reverse. And then the interior one here, simply when that is depressed, stops the motor. Here is the first test run of our unit. So there's a pretty large load of manure here, and hay as well. And it's doing a pretty decent job overall. You can see there is some spillage on the top here, but overall it did very, very well. And if need be, we can add more material to make that scraper taller. Here is some problems that we encountered, and Colin will address those.
So a few of the problems we encountered, one being the electrical components of our project. Being that we are strictly mechanical students, we only have dabbled into the electric field a little bit. So that being said, it wasn't that we weren't able to do the electrical component, it was just more of a big struggle for us because we were so unfamiliar with it. But thank you to John there, we were able to figure it out and get it done. Advice for future groups, definitely if you aren't familiar with the field you're working in, start it as soon as possible. Get that out of the way, then you don't have to sweat it towards the end. Another problem was shop time. We found ourselves working over one of our vacation weeks in the shop just because there are other classes that need to be in the shop. At the same time, we were trying to make our alley scraper. So for future groups, just get your design work done as soon as possible and get in the shop and start cranking out your parts. Also, ordering parts, just maybe a mix-up in part numbers on our end or the other end seemed to be a slight problem. that and getting things in a timely manner. We found ourselves, we were waiting on some of our electric components up until the last couple weeks or so that we needed to complete our project. So yeah, for future groups again, just make sure you get your part numbers exactly right, get your stuff in on time. Advice for future groups. We were definitely lucky enough to get this group here that I have worked with. We got a great project. We didn't get bored with it at all. It was definitely a challenge for us, which I think was definitely good, kept us interested in it. That made it a lot easier to keep coming in day to day to get the project done and installed for our client. Improvements. For one of two of our drive sprockets that pulled our alley scraper, we outsourced to get those manufactured, which at the time seemed like a good idea. It was relatively inexpensive, but when we got those parts in, they were cast, so they weren't exactly held to tight tolerances. So we found when we did our first little mock setup, the chain was binding on our sprockets, so we ended up taking an angle grinder to it and trying to smooth those out as best we could to get them to work. But in the end, they worked flawlessly. We haven't had a problem with them. Also, the overall height of the alley scraper. You saw there as some of the manure fell up over the top of the arm. If we were to do it again, you would just make that a little bit taller, add another 4 to 6 inches on it, and that wouldn't be a problem at all. And then with our detachable chain that we used as well, for some reason the company decided to spray paint it for some reason. So that seemed to be a problem as it was binding up and getting all over the place and just not working out for us. So we ended up putting that in a part cleaner overnight and stripping all the paint off of it. Special thank yous to all who have helped us: Roger Howes, Joseph Correo, Ken Vandermark, Jeremy Cornwall, Mike Wright, David Rice, Travis Allen, and Bob Royce. So round of applause for all of them. Thank you so much. Any questions for us? Yes.
I'm curious, you just run an FEA on the load that the manure would cause on the...
Right, I'm going to let John handle that one.
Fortunately, we were lucky enough.
Might you repeat the question? I think a lot of us can hear.
Yeah, repeat the question.
Could you have ran an FEA on the load?
Could I have ran an FBA on the load of the scraper arm?
Yeah, that it would experience moving the manure?
Fortunately, we were lucky enough to not have a strenuous, heavy load that required finite element analysis. Yes, we did do a finite element analysis, but we didn't put it into our PowerPoint due to the fact that we had so many groups before us that had it. Does that answer your question?
Well, do you know how much load that experienced?
We calculated out a 600-pound manure load for our scraper and applied that load to a finite element analysis, which gave us great results with plenty of room to go. Any other questions? One of you two gentlemen?
Yeah, two questions. First, how did you choose your team uniform?
Well, since we all work so well as a group, we thought we might as well look well as a group as well. So it's kind of all came together.
Real quick, I guess actually two. One is, can you comment on what needs they might have as far as keeping the chain and the limit switches clean and operable against corrosion or just getting jammed up because they're in manure? And you also mentioned using some steel and also Delrin. And I wondered where the Delrin was in your design. I didn't catch where that was.
Sure. So with the chain and limit switch issue, the limit switches are inside the barn, so they don't really see weather too much, and they are sealed component. They're an electromechanical switch, so the mechanical part of it doesn't really interfere with it. The electric probe never really sees the cab manure and whatnot. And with the chain, it is